Welcome to my channel. In the previous video we have seen this curve which represents IC. We have here IC equal to beta multiplied by IB. To see this curve on the scope, I come across with this schematic. We have here our BJT transistor. To vary the base current, I used a optocoupler with a sine wave generator. We have here 220 ohm to protect the diode, the internal diode of the optocoupler. Here we have the base resistor RB, which has 10K, and here we have the collector resistor 100 ohm. I used 5 volt power supply with my power supply, but be careful here, the power supply mustn't be connected to the ground, because we will connect the ground of the scope here. If your power supply has this plug, you can use it. Otherwise you can use a battery here, a lithium battery for about 4.2 volt. So this generator will vary the base current, and here we connected the scope in the X-direct mode. In the X axis we have the IB. This is the X axis, and the Y axis we will connect the probe here in this place, the collector, because when the current flow over this resistor, this voltage will be proportional to the current. I made this circuit here in this breadboard. You can find here, this is our collector resistor, this is the base resistor, and this is the resistor for this tiny optocoupler. I will zoom here. The stop probe goes to the scope. Now I will power the circuit and we will see the curve. I powered the circuit with 5 volt from my power supply. Here we can see the curve. This is for the IB and this one for the IC. I can vary here the voltage. This curve of the base transistor, we can see here that our generator here is output a sinusoidal function, but this optocoupler can pass the current only if the voltage is above 0.6 volt, this junction. So we will see this curve we have in this shape, the same here, and this part here represents the saturation current. Now I will switch to the X-direct mode, the time base. You can find here our small curve here. I will vary now the power supply, the voltage. We can see here that we have a variation here. I will switch to the analog scope to see better this curve. Now I will switch to this Tektronix 2225, which are really functional. Now I will increase the intensity. I will decrease the voltage. Here we can find our curve. The slope of this line represents the amplification coefficient beta, and here we can find the saturation current, ESAT. Now we come to the end of this video. Thanks for watching and have a nice time.